ideas of PSM. Uh, we have seen in the past incidents like Seveso or Bhopal and such incidents being recounted. Normally, it takes about 15 minutes followed by question answer and all. The other part of the meeting is what we call experience sharing. And again, experience need not be with someone who has only 30 years of experience. It could be also with having someone having only 3 years of experience, or maybe only 1 year of experience. But he or she feels that yes, we need to share it. It is so important that I feel like sharing it. Normally, it should be or it could be lessons from my personal failures. That is most important lessons that we learn. When we fail, we learn more sometime than when we succeed. And it could be not necessary regarding some incidents, but it could be about some project, about some task, about some program that was implemented. I was part of that. So that is what we are talking about, experience sharing. And again, we have seen a lot of good presentations. Now, another thing I want to remind at this point is that nobody need to give a PowerPoint presentation. This is sometimes this is a very misunderstood process. You have to give a talk. You want to use a PowerPoint, it is up to you. You want to use a one sheet PDF, it is up to you. Sometimes you don't want to use anything, you just want to talk. In your hand, you are keeping a sheet uh, just to keep you in the flow and reminding a reminder sheet, check sheet, but you don't have to present it and you keep talking. That is what is required. And why I am explaining all this, because we want to encourage people to come forward. We want that maybe 2, 3, 4 months in advance, this is booked by all of you, because this is a platform for everyone. So you call Ramana, you call someone, and you tell them that, look, I want to do this. Do you have a slot in next month or a month or in June or in July? And we book, because that is how the date and timing of these meetings are already prefixed, decided in advance. Every third Wednesday evening, 7:30 p.m. we will have. Right now we are having 8:30 p.m. because of Ramadan. So I request all of you once again that please come forward. Unfortunately, this month we didn't have anyone coming forward. I'm so surprised. I'm so sad, I should say, also, that people didn't come forward to do any of these two. So now we are presented with a dilemma what to do. Go ahead, just do some networking and close the meeting. Then Mr. Ramkumar, he came forward with a solution, and he said that he wants to talk about learning. We said, yes, why not? Although, let me again clear it, the meeting is not a platform for training. This meeting is not a training session. In 15 minutes, in half an hour, you don't get a training, any meaningful training, I mean to say. You have to spend some time for the tutor to present something, give details of that, and come down to that after attending this training, he or she will take us from this point to that point. But in this one, we are not talking about that kind of training. So many people, they came forward and they said that they can talk about HAZOP, they can talk about QRA, they can talk about, you know, they are fine, they are most welcome, but not for this meeting. Let's organize a separate training session, which chapter is already doing. And if you have a training to deliver, why not? A seminar to deliver, go ahead. Speak to chapter, propose your, come forward, and, they will find a spot for you. However, this is not a platform for that. So, Mr. Ramkumar, he came forward and he talked about this, that I want to talk about this, how this, experience is important to a sound culture, a sound safety culture, PSM culture. And that is what he is going to present now. Now, going back to incidents, there was still no one to present incidents. Then we thought upon the idea that, okay, in April, we had some major disasters, major PSM incidents. Rather, they were not initially considered PSM incidents. One was Chernobyl nuclear power plant, disaster. So many people died and so much of radiation fallout was there. And as they say that it may take 20,000 years for it to be contained. So it was, as it came out later, that we have lots of things to learn as a PSM student, as a PSM practitioner. We have to learn from Chernobyl incident. Similarly, Deepwater Horizon, it was a platform and upstream business. However, as you know that it happened in April. In July, finally, the the Chemical Safety Board (CSB), they were given the task as a PSM, chemical incidents, to investigate, and then onward it became a PSM incident. So these two major incidents happened in April. Deepwater Horizon, 20th April, yesterday, and Chernobyl, 26th April, 1986. So I thought that it is a good idea. Let me spend some time recollecting as to what are these incidents. But when I was preparing this, suddenly, I was watching a TV program and I saw this Titanic movie. Many of you must have seen it. And then I realized, oh, Titanic also happened in this very month. So what I have done is that I am going to take a little time. I had some previous presentations which I made for my previous company. I have edited those three presentations and I would be presenting to you about 15 minutes each, so that you get to know what were the incidents and what were the PSM lessons learned, so that you get a better idea instead of just giving you the headline. Uh, so with these few words, let me, and of course we will have time for networking, knowing each other, and question answer, very importantly. So I would now request Mr. Ramkumar to take over and start his uh, kind of, let's say, presentation. The title is Disasters at Process Facility, Developing a Sound culture, safety culture, potential learning with experience. Mr. Ramkumar, he's technical supervisor in Kuwait Oil Company. I personally know him since many years. So please, Mr. Ramkumar, the stage is yours.
Thank you, sir. Give me a second to pin my. Good evening and welcome, ASSP's distinguished guest, my gurus, and wonderful President Jahid Thakur, Executive Committee members for giving me the opportunity to present in International ASSP Kuwait chapter. Today we are going to talk about disasters at process facility, what it comes to you, disasters. And we also enhance ourselves potential learning with our experiences, developing a sound culture. In other words, we can say commitment to safety culture. What is the purpose of today's presentation? To look into the learning from the major incidents, chemical disasters, analyzing what are the three causes of accidents, and we also look into four important elements of process safety management, which become a key learning point of view. We all know about the process safety. We all study, measure systems, procedures that is mandatory, regulations, the policies for what? To prevent incidents, to protect people, our environment, and the property from these major accidents and disasters. Then, what do we mean by major accidents? Perhaps we have experienced just now, Mr. Ujjwal, my guru, he said, we have learned from the Seveso, Chevrolet, Mexico, disasters, Piper Alpha, Texas, Deepwater Horizons. What it has impact, not just monetary loss, people, fatalities, injuries. Significantly, it costed hundreds and thousands of people died because of poor process safety. So process safety is always about the management of the processes, focusing on building layers of control measures and the protections, ensuring the likelihood of such an incident is as low as reasonably practical. Now, chemical disasters or accident disaster, what it comes to my mind is how much ozone layer is depleted, environmental is being in the impact because of chemical accidents and disasters. Our ecology, the impact would be short term and long term, which we have seen in the Bhopal case studies. Even today, Nagasaki, Japan, Hiroshima bombing, we still read, and again, we learn from those kind of incidents which have left a major disasters across the world. I'm talking in the scale and depth of human loss. What is important to us? The living organisms. How healthy we live. How healthy is our environment? That is a concern to all the HSSC professionals, not just limited to process safety engineers. I would like to reflect on the case studies about some of the major chemical accidents that took place. Bhopal Tragedy, everybody knows, 1984, December 3. The cause of it was simple. Safety systems were not functioning. Many valves and lines were in poor condition. What was the chemical? Toxic chemical methyl isocyanate, which escaped 40 tons from the Union Carbide pesticide plant. 25,000 people died in 1994. But in the year 1984, there were 2,500 immediate fatalities. But after 10 years, we still suffered with the injuries and fatalities. Not just limited to the cost, 470 million spent. Now, what is all about? The lessons learned is all about is it has promulgated the laws, environmental protection laws in 1986, industrial factors, Factories Act of 1948, which was amended to regulate the facilities that is dealing with hazardous and toxic chemicals and materials. And it has become a Public Liability Insurance Act in 1991 was followed based on the waste rules being implemented in 1989. There are other environmental pollution rules were amended in 1992. So wherever the disasters, there are always lessons. Second incident I reflect upon is the Visakhapatnam, the major failure industries of India, which occurred in 1997, September 14th. Drop in pressure, as such, what happened? Shore compared with that on the ship implies a leak, and that leak ignited. Fire broke out, and it caused a series of explosions in the sphere of LPG tanks. Now, what happened? LPG leaked for several hours and nobody could identify it, as imported LPG was odorless, colorless. Now, I would like to reflect what are the lessons from these two case studies. There are a lot of other incidents like Sivaso, Flexible, Bhopal, Piper Alpha, gas leaks in Mumbai. But here with these two lessons, I would like to reflect the three causes of accidents could comes to my mind. And we all know one, process analysis, identifying, analyzing, and you need to be producing the solutions, not seeing upon the problems and the same issues what we have when it comes to the process safety or a culture, to commit to the culture. Then implementing the solutions and changes, any organization that look into the changes with zero incidents being a focus in his mind, definitely they will have a remarkable results. So in the lessons, in the process analysis, identifying comparative mixtures, chemical parameters, possible corrective measures in the cooling system, heaters, containments, identify physical consequences of the toxic releases, explosion, and or fire before it strikes or into disasters. Second lesson, what we can learn from these kind of disasters is safety measures and controls, how effective they are. We all know we need to adequately follow the safety measures and controls while handling, storing, or transporting of flammable or toxic substances. But do not simply choose a control method because it's easy and fast to implement. Understand that your key priority is not PP or administrative control. It is about engineering control, substitution, and the topmost priority is the elimination of oxidizing agents. We have evidenced nitrogen peroxide, which happened in Lebanon. Eliminate ignition sources, static electricity, hot surfaces, and sparks. Critical process ensures sensors, alarms, and sensors. These are all our parameters regularly. We need to check and look into how effective they are within our maintenance system. Now, I would also like to go through third important cause of chemical accidents, organization measures. Now in the PSM, we have 4 items we can ensure that commitment to process safety. In the Center for Chemical Process Safety, 5 elements are exclusively written to lead from the top management, embedding the process safety as a core value by which we all commit to process safety. And 2 elements is approaching enabling businesses to review information and share that resources appropriately to understand hazards and evaluate the risk. Third, 9 elements, which is talking about the continuing execution of the risk-based process safety, how to effectively manage those risks. If you have a high risk, bring it to moderate and moderate to low. Identify your risk assessment. Learning from the experience, do we learn from the experience being the lesson shared? There are 4 elements which is talking about information from incidents, providing feedback, how the process safety management is performing. So workers training is key, important to be given. Housekeeping to be implemented, emergency response, prevention, protection, mitigation, response and recovery, how soon we respond if there is an incident happened. That is a key concern as a process engineer. Are we trained? Are workers trained? Are the contractors trained? How effective is our PSM management system? Implement correct labeling rules, effective communication, and supervision is equally important in maintaining our process facility layouts. Let us quickly look into the process hazard analysis in preventing accidents. We do a lot of process hazard analysis. We look into the key studies, what if analysis, how we do it, what we do it. Just a second, my screen is gone off. I don't know why, but yes, I'm okay. Failure mode effect analysis, fault tree analysis. PHM, these process hazard analyses are essential tools to determine locations of process safety, identifying corrective measures, and prepare effectively, validating your emergency action plans if your control system, safety control systems fail. Measurements and matrices. Can you hear me, Ramana? I cannot see you.
We can hear you, Ramkumar.
Okay, I'm going ahead because I cannot see anybody. My screen has blackout. Fine.
Okay.
Measurement. Ramana, you can open the slide measurement and matrices if you can see.
No, we can see your slide, Ramkumar. Please
Okay,
keep
sir.
going.
Okay. Now I am in the slide measurement and matrices. How can one show the evidence of process safety success? We are all process safety engineers. Sometimes.
Hold a minute. Hold a minute.
So,
What we see here is a PHA slide.
Yeah. I will stop it.
yeah, just
Maybe
go to
Ramana, you take over.
Yeah,
Yeah.
please take over and put me the slide measurements and matrices.
Okay.
Thank you. I will say next, then you move on to. Keep the slide measurement and matrix, Ramana, if you're okay with it.
Yes.
If it is there, just say yes, ready.
It's not there in that presentation.
It's there, it's there. Measurement and matrices, slide for 11.
Yeah, okay.
Got it?
Okay, go ahead.
Thank you. Let me quickly wrap into the measurements and matrices. What comes to your mind when we talk about the qualitative and the quantitative? It is all about our process safety, how successfully we do our measurements. Relevant to process safety matrices, the key things are leading matrices, lagging matrices. Leading are performances based, where the key work processor, operating discipline, and layers of protection that prevent incidents. In contrary, lagging indicators are a retrospective set of matrices, that is what based on incidents, accidents that meet the threshold of severity that should be reported as part of the industry practices. Again, is the safety matrices. So the challenge of safety systems is all about what we have here: dependable, do leadership visit or managers visit, site visit is there? If it is there, what frequency? What percentage managers and supervisors, process engineers are trained? And the percentage of the meetings being held Our workers or contractors or the persons or the people who are involved in the process safety are suitably rewarded and recognized, because without motivation, the safety will not be sustainable. So worker motivation is equally important. Performance matrices also can be considered process safety events and incident rates. How many? What is the frequency? Second, we talk about the developing number of open recommendations and the process safety suggestions monthly reported. How quickly we are closing those recommendations, or is it just relevant to the shelves or is the paperwork? Are we really concerned about those recommendations to prevent the incidents from recurrence? Yes, that is the key issue. How many employees are participating and are giving the process safety suggestions monthly program? Each and every employee is unique. Perhaps we can have a toolbox talks, meetings where the employee suggestions relevant to the process safety, from the leak, spill, or the pipeline or the corrosion, whatever the items they identify. We need to adhere, we need to take it seriously to address those issues. Now, matrices should also be taken into the consideration like we always do, beyond unsafe acts and unsafe conditions. Are the workers following safety behaviors? Are they using the shortcuts and unsafe acts in our refinery or operations? And are there any number of near misses reported and have they been addressed? What should be the response time to complete incident investigation? These are some of the key matrices or measures we can consider into the process safety elements. Next slide. Establish incident investigation strategy. What should be the strategy actually? You see there is a three different colors onion: root cause of analysis, incidents, underlying causes, and how we do it. We do what if analysis, checklist, and internal external auditors we involve and do an analysis on what went wrong and what is the actual root cause of the analysis. Investigate every process safety incident to determine the root causes. Competent professionals will never happen. Once you dealt with the incident, when you go through the incident area, the site, and you measure things, the frequency of the things, we always seen the Swiss cheese model. Every factor, every incident leaves us a lesson. Measurement is more effective when you perform effectively. Share the lessons learned, whatever the little incident. Don't look for the catastrophic incident. Any minor incident could be major. Major incident could lead to devastated and disasters. Auditing, whenever you consider for the PSM audit, ensure that there is a continuous improvement process is there with all the 20 elements identified at the Center for Chemical
Ramana,
Processing.
next slide, please.
Yeah, Raman, next. Thank you. Meet the organization key goals. What is the organization point of view? No deviation to the document, zero incidence rate. Verify the PSM elements and understand why we need to do an audit. It is not for just the practice of doing an audit. It is not just a number, but it is a improvisation. Everything you deal with, each and every component of a process, unit, or a facility layout. This is for your continuous improvement. Next slide. Another important element in the process safety is management review and continuous improvement. Knowledge is one thing, hazard identification, with that we can control if we have effective hazard identifications and control measures. Participation in management. Employee participation, if it's not there, effective training is not there, your system won't be continuously improved. We will be there where we are. So incident learning and response is all equally important when we operate, analyze, and improve our processes to improve in the refineries. Review of the management system performing and producing the desired results to meet the desired expectations and functional process safety will achieve only when you commit to the process safety measures controls, safe operation procedures. Overall process safety management is the responsibility of the management. But as we say, safety is everybody's responsibility. Process safety is also equally responsibility of every individual is working in the organization. Perhaps administration control, management control, hierarchical control, but each and every one can play a mutual role. Next slide, commitment to process safety. Here, I would like to emphasize on safety culture. Pathological, we are not pathological anymore. We have evolved seeing the major disasters and chemical disasters over and again. We are supposed to be reactive, calculative, proactive, and the most important thing, focusing on the generative. How effective is our safety management system? How effective is the process safety management system? Are we complied with the 20 elements of the process safety? How better we can do with everything around us? Worker involvement, how effective communication is there, and mutual trust and responsiveness. When you commit something, you do commit. When you go and inspect your plant facilities, storage tanks, pressure vessels away from your office or comfort zone, we rely on the process engineer or operator or safety professional. That's called a mutual trust. We are not filling the checklist based for the sake of filling it or just for the code practices. As a regulatory, it is mandatory to show the auditor that we need to do the checklist. No, it will not. So positive commitment to safety culture will effectively develop sound culture within the process safety. Further to which, look into the warning signs. There is always a sense of vulnerability. It will not happen. Even you see, whenever the processes are not effectively performing, even in a car when we are driving it, there are some noises, but we ignore them, then your car stops. Not eventually or immediately it will fall. However, there are natural threats also, like earthquake, tsunami. Such things, it's not in our hand. Terrorist attack, it is not in our hands. But process safety, all incidents are preventable. Understand the importance of the risk assessment and how to mitigate those risks. Ensure proper and open communications. Speaking freely one-to-one whenever you do the audit. Don't go as a process engineer, go as a worker. Visit each site and talk to them. When was the last audit happened? Was there any incident? Yes. What was the lesson? Was the lessons learned? Was there any publication on the latest root causes analysis? Were there any refresher training? Ensure production pressures and odd ill safety priorities. Understand the importance of next safety culture growth, Ramana. Let us go to safety audit. Ramana, are you with me?
Yeah, it's already there.
Thank you. Understand how important it is for you as a process engineer, as an operator. Do a self-audit assessment. What does it mean? There are different, we say the front line workers are equally important. Here in this slide, I would like to reflect on incident investigation team. Do you have it? Yes. Rate it. Be honest and commit to the process safety. Understand at what level you are. The best rating I see is 3 and 4. For example, 0, incident report completed by victim and witness. And how it will be effective to me as a management perspective, as a controller perspective, as a process engineer to you. The more impact will be, organizational learning is there, our team building is there. Employees and managers are led by those with greatest expertise on the task, which I evaluate as selection level as 4. Now, planned maintenance. We always talk about the maintenance. Preventable disasters, lack of training, non-operating personal safety awareness, lack of motivation, lack of effective recognition, operating instructions, or living in false sense of security, living in false pride, and focusing on the public image. This will not solve problem. Maintenance periodic maintenance, predictable, preventable maintenance, and if you have a catastrophe, how do we have a scenarios developed? How we mitigate those disasters? Prevention, protection, mitigation, response, recovery. These are the continuum of emergency response if you have to look into. Frontline workers have control and responsibility for the maintenance. That's true. But what you as a process operator, our job is to ensure that assets are reliable, integrated, and embedded to the process safety culture, having following the all 20 elements of the process safety management. Let us come to the rules and PSM procedure. What we understand from this, is it just a rule that we need to maintain because we are legally required and obliged to follow? No. It depends on our safety rules that acknowledge changing demands to make it easy to comply with standards, guidelines, rules, and safety operation procedures beyond standards and regulations. In order to summarize, if anything would go wrong, will go wrong, and did go wrong, like what we have seen in the methyl isocyanate, Bhopal, Sivaso, or Visakhapatnam petroleum refineries. What we have in our hand is how well we manage. Learning experience is something that entire life is a learning process, and it's an experience that counts today. Key to success is through a sound safety culture, which is employee owned, management driven, operationally consistent, that maximize creativity and innovation. Adopt to change. Earlier we had 14 elements, today we have 20 elements. How many of us are looking into risk-based process safety elements, following the Center for Chemical Process Safety Board? Do look into it and have a sense of responsibility. Adopt the culture belief that all incidents are preventable. Have a vision of zero incident concept. Conceptualize your process. Conceptualize your continual cultural improvement that the entire workforce can be proud of you and your organization. Understand that our people, asset, equipment, and organization reputation is paramount. Thank you. If you have any questions, I am open to you. Thank you,
Yeah,
sir. Back to
Ram
you.
Kumar, thank you very much. And at this point of time, we invite a few questions. We will take before we go get into the next segment of the meeting. I see quite a lot of people from Australia to Argentina. So
Excellent.
I'm happy that this forum is getting popular. People are finding it of some value. Go ahead.
Yeah, there is a question in the chat box.
Yeah, can you?
Yeah. What are
Can
the
you read?
standards and codes should be followed to produce effective implementation of on PSM? Is it like general? What are the standards and codes should be followed to produce effective implementation on PSM?
See the OSHA, first of all, take the OSHA, we have 119. And we can always refer to the Center for Chemical Process Safety Board. Any elements, 20 elements are equally important. We do not prioritize that this element is important, or we choose that other elements are not important. All elements are important. I suggest to refer to the OSHA 1910, 119, Process Safety Management, or refer to risk-based process safety, which has clear guidelines based on Center for Chemical Safety Board. Thank you. Next question.
Okay, there are a couple of members raise their hands.
Yeah, go ahead. You can unmute yourself.
Yeah, no.
And
I'm unmuting them one by one.
right.
Mr. Muhammad Musarat Abbas, please unmute yourself.
Yes. Am I audible to you?
Yes, very audible. Please go ahead.
Okay. First of all, thank you very much, Mr. Ram, for this comprehensive presentation and making us aware of the safety culture and PSM thing.
Thank you.
Really appreciate it. The primary question about the thing that you mentioned about the incidents and near misses in one of the slides. The question here is that for the PSM thing, we know that usually tier 1 and tier 2 incidents get reported, whereas tier 3 and tier 4 incidents are primarily for the organization to self-improve themselves. But how can we draw this line between the near misses and tier 3 incident? Because as per CCPS that we have also quoted, they say that there is a threshold for the tier 1 and tier 2. Below that threshold, we can take it as tier 3 or near miss. So what is the thing that will distinguish between tier 3 and near miss?
According to my knowledge, near misses are the first incidents that need to be addressed whenever when we have a report from any cross-sectional or functional areas, anybody, irrespective of the process engineers. When you talk about the tier 1, tier 2, it is escalation of the incidents. So which shows that focusing on some of the developments like maintain a sense of vulnerability and what is important to you based on the risk assessment, establish questioning and learning environment to foster the trust between you when you develop the risk assessment. Now, when you talk about the tier 1 to tier 2 or tier 3, how important and how your risk assessment is based. Is it a qualitative or a quantitative measures? We need to take into consideration some of the common causes of incidents that is prevalent and frequently occurring also. So overall, if I have to look into your question, I would like to reflect some more thoughts, but we have an expert here, Ujjwal Ritwik sir. If you can add some value to his tier 2 to tier 3, sir, risk rating.
I mean, the issue is that we are still referring to a term called near miss, right from the day that this term was coined as part of PSM, uh, PSM subject. This has been always a term of controversy. Near miss has not been defined uh, the same way all across the practices. I would say Center for Chemical Process Safety, they define near miss, process near miss, when I say, in their own way. And later on in Europe, there were some definitions available, near misses. They were a little different. When the API 754 came in being, there was intense discussion, argument, and they decided to drop the term near miss altogether. Instead of that, they have gone for this tiered convention. So if you are drawing a parallel between near miss terminology or term defining term near miss and API 754, you will find some notes within API 754 guidance where they refer to near miss. At the end of the day, you have to decide yourself what you call near miss. But when it comes to your near miss, it remains your near miss. That cannot be compared with maybe other companies who may have their own definition. So when you are going for comparison between the companies, company to company, or between countries, or between sectors, etc., etc., you have to confine yourself to tier 1 and tier 2. Tier 3 and tier 4 are meant for within the company or within the corporate body. If suppose your company is having 4 or 5 sites, you can compare on tier 4, tier 3 and tier 4. And accordingly, you have to. And when you are comparing near misses, then you have to go for, you have to have a footnote that this is as per, let's say, CCPS definition of near miss, and then you talk about that. So keep them separate. They are not the same thing. They could be almost same sometime, but they are not the same thing. Hope this resolves. Maybe you can separately talk about it, with me or with other people, or maybe I would say that first thing is that you go back to API 754 when you are talking of tiered measurement process for PSM. Okay, so we stop this discussion here at this point, and we will take it again because we have to continue with the agenda. And our next segment of the meeting is about introducing the new people who are joining this platform. So, can I request those of you who want to introduce yourself, we encourage that you come forward and introduce yourself. It will make everyone happy that yes, you are on this platform, and they can talk to you, they can get back to you. That's what it is called, networking. You need not be super duper specialist in PSM. You can be someone like me on the learning path. So go ahead, introduce yourself. Just raise your hand, and Mr. Ramana, he will unmute you, and then you can talk.
Yeah, Mr. Venkateshwar Rao.
Uh, yeah, good evening to all. This is Venkateshwar Rao. I am from India. I am the HSC professional. So coming to one point, overall PSM system is the responsibility of the management. Due diligence. So due diligence must have what is the both how it helpful to PSM. That due diligence is how it support to PSM, how to help due diligence. One is the process management that Ram sir is told that due diligence regarding. So how it helps to PSM.
Good evening,
Yeah, good evening, sir.
Venkateshwara.
Yeah, good evening,
Yeah,
sir. Good evening.
it must be quite late in the evening there, out in India. You are very much welcome to this platform. We are so happy
Yes.
to have you.
Welcome, welcome,
What
sir.
kind of work you are doing?
I'm doing regarding my job.
Yeah.
Actually, I am a marine specialist, sir. I'm a HSC professional
Wonderful.
marine specialist.
Mm-hmm.
In my project, I have done my Iceland breakwater. I have done my jetty projects. I have done an LNG tanks.
Great. And you got interested in PSM? Any specific reason?
Oh yes, sir. That the continuous process, Sir Ram sir is told that regarding due diligence. So
No, I'm not talking about your question. See, at this point of time, we can talk about your question toward the end during networking time. Right now, we want to know who you are, what you are doing, what got you interested, etc.
Okay.
So, see, this is a forum for process safety practitioners.
Yes, sir.
So, how did you come to this process safety business?
Yes, sir.
Okay, thank you very much for joining this, and we encourage you to be with us every meeting on this forum. Can we have the next person
Yes,
who would like to introduce herself or
yes,
himself?
Mr. Venkateshan Murugesan, please. Mr. Venkateshan Murugesan, are you there?
Mr. Venkateshan, can you introduce yourself, please?
He's not unmuting. Please unmute yourself. I have given the permission. Okay. Next, Mr. Mohammad Imtiaz.
Yeah, good evening.
Welcome, Mohammed.
Yeah, thanks, Mr. Ujwal, and thanks to Mr. Ram Kumar for excellent presentation. Name you already know, Mohammad Imtiaz. Basically, I'm working in Qatar with the leading petrochemical industry, and my experience with process safety is approximately like 2 years old. Overall, I'm having a experience of 4 years, so it's been a very good journey, an excellent learning opportunity, and especially we are based on the OSHA PSM system. And then regarding a short introduction about my profile, that I'm having many different certifications like ASP and just in the process for CSP. And so it's an excellent opportunity. This is the first time I'm joining this meeting, and now I have even marked that it's happening on third Wednesday of every month. So definitely I will be signing it every month. Hope to learn
Wonderful.
from you.
You are most welcome, Muhammad Imtiaz. We are happy to have you in this, among us. We are all learning, and we wish you a wonderful career ahead.
Thanks a lot,
Uh,
sir. Thanks a lot.
Great.
Thank you.
Next,
Yeah.
Anna?
Anderson Gary. Please unmute yourself. Anderson Gary.
Good evening, everyone. My name is Anderson
Good evening,
Gary.
sir.
My name is Anderson Gary. I'm from
Good evening,
Mombasa,
sir.
Kenya.
Yeah,
from
Mr.
Mombasa.
Anderson, go ahead.
And I'm also a safety practitioner. My work as a safety, I'm in charge of safety in logistic industry, and we are also doing warehousing. So this is very informative and educative, especially since I'm also in charge of handling chemical substances, and we are also warehousing them. This platform is very educative and it is really informative. This is my first time to join, and with time I'll be part of you members because I've really enjoyed the knowledge that you've shared with me, and I've really learned a lot, and I'm really looking forward to have more time and share more things with you guys.
Good, very good, Anderson. And how is the weather in Mombasa?
Mombasa right now, the weather is a bit mild because we experienced some few rains today, but still it's a bit hot.
Okay.
Yeah.
Wonderful. And please remain with us, at least if not in other events, at least these meetings monthly, every third Wednesday of the month, and encourage your, people around you, similar people who are, on the same boat, they can also join. Welcome again.
Sure.
Ramana, next person, please.
Yeah. CPVM Paula. Could you please unmute yourself? CPVM Paula.
Okay. Hello, everyone. My name is PSM Pala. I'm from Zimbabwe, Africa. Currently, I'm a student who is studying towards safety, health, and environment. And also, it is my first time joining this platform. Thank you so much. I really learned a lot as a student. I've learned a lot on process safety. Thank you so much.
Welcome, CPV. It is very heartening to know that even as a student, a college, university student, you are interested in this kind of activity, and I can assure you that the more you participate in these activities, the more you learn yourself, and of course, you will make a good career. So wish you best. Keep coming back to this platform, and if you need any assistance with the Kuwait chapter, PSM forum will always be, there are many experienced people who can always be helpful to you. Wish you all the best, CPV.
All right, thank you so much.
Romana, let's have one more or a couple of more, and then we will get back to the next part.
Venkateshan Murugesan, please.
He is back?
Yes,
yeah,
sir.
he's back.
Good evening, sir.
Good evening.
Good evening, Venkateshan. Can you introduce yourself?
Yes, I am Venkatesan. Right now, I am in Kuwait only.
Yeah.
I am working in Kipik. I am in new project. I am working in tankage area. I mean, tank storage oil terminal as a operation supervisor. So I like to do this process safety management course. So before I don't have anything idea for this course, but now I like to do this course. So what I should do for this course?
Wonderful. It is a very good, it is very encouraging for us to note that people like you are interested. And I think Mr. Ramana can contact you separately, or rather you can contact Mr. Ramana and talk more detail about the upcoming PSM 60 International Certification course. Let me just give an additional sentence on that for many of others who are interested, who may be interested, is that this is an international course. Unlike many other courses, I have seen CCPS syllabus, I have seen Institute of Chemical Engineers UK syllabus, or even NABOSH syllabus. They are, more focused to their respective regulations or a certain branch of practice, whereas this international course, and that is why we have named it international course, because the syllabus is more international in nature, especially for practitioners in Asia and such places, Africa, where ICHE or CCPS is those respective country regulations are not so much in use. So we will keep you informed, and those of you who are interested, yes, please go ahead and talk to Mr. Ramana separately. You can write a mail to him, and he can keep you, registered for the future course. Let's have someone, the last person, maybe somewhere on the east side, Malaysia or Australia, somewhere, who must be sleeping now or who would be about to sleep. So just Ramana, if you can get someone.
Yeah. Okay, there are a couple of guys, but Mr. Muhammad Musarat Abbas like to introduce himself. Yeah.
Yes, thank you very much, Mr. Ramana. Basically, I had the pleasure to ask the question earlier, so I just skipped the introduction part. I am Muhammad Musarat Abbas, and it's my 8th year, currently serving in oil and gas upstream sector in Pakistan. It's 8th year, and the 6th year were in operations and process side, and now this is the 2nd year I am actually serving as process safety management and sustainable development engineer. So obviously this forum is a great networking effort by you guys, and it would also be very fruitful in technical discussion as well as how we are going to develop as an industry with respect to process safety. So a very encouraging event and very encouraging initiative by you guys. Really appreciate it.
Thank you, Mohammed. Welcome on
Thank
this
you.
platform. It is our honor that you are here and you can share with us your experiences. As I have been telling, that this platform, it is for people like you to come forward and talk. And we would expect that next time you would come, you would present your experiences, your case studies, etc. So please be with us, continue to be with us.
Sure. It would be an honor for me to be representing on this forum.
Great. Ramana, let's have the last person before we move to the next section.
Mr. Vineet was here just now. He left. He raised his hand. Mr. Vineet Vijayan Pillai, are you there?
Let's go to the next one.
Yes, myself, Vineet.
Vineet. Okay.
Yeah, hi. Good evening, all. Myself, Vineet. Actually, I'm working with KNPC right now as a safety supervisor for the maintenance project. Actually, we were handling the catalyst maintenance in Mina Abdullah refinery.
Welcome, Vineet. What interested you to move to or to talk about PSM or to get interested in PSM?
Actually, the thing is that we were now more into the refinery activities. Like during maintenance time, we were more into the refinery activities. So if we are having better idea related to the process safety and all, it will be helpful for me to do the job the better and to make the people who are working with us more safe.
Great. So continue with us. We are very much encouraged by your presence, and we would like to see you in all our future events.
Okay.
Thank you, Vinay.
Okay, sir.
And thank you all. We are going to have some more introductions and talks, chats toward the end. So let's move to the next part of this event, and it is something that I would need to hasten up because we have consumed some time, uh, uh, rather more than half of the time allocated to this event. So I need to move fast. And can I, Ramana, can I make my screen appear?
Yeah. Okay, sir. Now you can.
Okay. Okay, can you see my screen?
Yes, sir.
Do
Clear.
you see a ship?
Yeah.
So this is the ship which was more than 800 feet long. And my story starts with this. Now, when you see a ship, you may not connect it to PSM or process safety. But I told right at the beginning that even though something, an incident or a project or a program, it may not be directly, connected with process safety per se, still we have when an incident is analyzed, we can infer some connectedness or at least some learning from process safety point of view. And that is what I had promised at the beginning. Now I added this section on Titanic because it happened that 15th of this month was the unfortunate anniversary of this unfortunate incident. So we are talking about process safety lessons from sinking of Titanic. This is how I believe this is an actual photograph and not a painting. This happened way back in on April 14th, 1912. More than a century back. But this incident has got a huge relevance, the learning from this incident, and that is what we will come to see. So I am presenting three incidents. One is this Titanic, then next would be the offshore oil rig in the Gulf of Mexico, that is Deepwater Horizon, that is the name of that rig. And the third one, which many of us do not immediately connect with process safety, but it is an out and out, process safety kind of incident that we had in Chernobyl in Ukraine. That time it was in USSR. So the first one is Titanic. Now, many of you have seen this movie and you have kind of very good memories of this movie as they are, especially the one when the hero and heroine, they are at the on the tip of the boat or the ship, and singing song. Well, the incident, the tragedy was much more gruesome, much more kind of unfortunate. It ended up with over 1,500 passengers and crew losing their lives. Uh, it was called unsinkable ship by the manufacturers and operators, and they, the people who were operating this liner, who were operating, were on the top of the operations. They lost sight of discipline, and that's where we connected to operational discipline. And this is a key element of process safety: operational discipline. For example, the ship was traveling too fast. Too fast means what? It is not expected more than, I won't say more than design speed, but more than practicable or practiced speed. There were reasons, of course, why they were traveling so fast. I don't want to get into that. But this is an issue many times when we operate the plant, when we operate our facility, and we operate it too fast, pump too fast, more than what is normally accepted, and that is where issue, it should give us a warning sign. Captain Smith failed to heed warning. There were warnings about ice and icebergs in the area. He had reason, or he may have reasons, but he did not listen to those warnings. The operator, or wireless operator, radio operator, he dismissed some iceberg warning, and it may be taken, I mean, they have taken a fatal wrong turn. This again is an operational discipline issue. Many times the decisions are taken in the operating facilities, in the operational plant, chemical plant, petrochemical plants, refineries, upstream, downstream, pipeline. We take wrong turn. There could be reasons, but again, it is issue of operational disciplines. We will come to the issue of lifeboat a little later. Operating standards and regulations. Titanic was supplied with only 20 lifeboats. Now, a ship as huge as 46,000 tons should have, it was required to have, uh, it should have many more lifeboats if people have to be saved. But the act at that time, which is this 1894 Merchant Shipping Act, it required only 16 lifeboats. So it was issue of standards, having right standards and regulations in place. Again, a very process safety, relevant issue. Training, obviously, many of the crew staff, they lacked training in operation of lifeboats, and that is the reason that many of the lifeboats, they were not, they had enough time to have enough people on the lifeboats, but still those lifeboats could not be filled with the capacity, and they left less than the capacity, and because of that many people could not be saved. So one lifeboat, in fact, this is what the history says, one lifeboat could carry 40 people, but it had only 12 passengers. So at least 28 people could not be saved because of, as a simple issue of emergency training. Drill was scheduled, but it was not done. for reasons best known to the operatives of the ship. Safety devices, this is one of the most unfortunate part. I mean, some of the crew, key crew officers, they did not have binoculars. Now, this is a very cheap instrument. Searchlights, they were not having. I mean, it is right now, it is unimaginable that a ship of this size, of this expense, of this prestige, and they lacked some simple life-saving instruments like binoculars and lights, searchlights. So this is something that we need to be very, very mindful of. I have seen, people are not given some simple detectors like H2S, personal H2S detector. Now, this is a very inexpensive instrument nowadays. There was a time when I started my career, it used to be very expensive, very bulky device, difficult and not very practical to carry it all around. Nowadays, it is a size of, matchbox, a small matchbox. Anyone can carry anytime, can be, used, and after 3 months use can be thrown, even 6 months use. It can be replaced cheap. Still, people are not being given. So we are talking of safety devices, emergency backup. It is said that there was a ship called Californian around the around the area, in the vicinity, very close vicinity. But still they disregarded the call from Titanic to save, save the passengers. Again, reasons we can go in depth in a more uh, established presentation. But what I am trying to connect is to process safety. Titanic's builders tried to cut cost, and this is something immediately and out process safety and asset integrity and asset management issue. Everywhere, people who run business, especially private business, they need to run in profit, and therefore they have to balance the cost. And this is an ever running battle between cost and safety. Because if we have to improve safety, we have sometime we need to cut cost. But that is where the practice of process safety or practice of asset integrity comes in place. If I don't maintain my car, I'm liable to get into accident. This is a very easy formula. And that is what happened in Titanic also. And something, in fact, it came to light many, many, many years after this accident. You know when? In 1985, when from 3,800 meters within the surface, under the surface of North Atlantic, the wreckage was discovered, and the study, a good metallurgical study was done, and then it was found that it was an asset integrity failure at the heart of heart. At that time, there was no welding. So the two steel plates, they were being, not welded, but they were being riveted. And rivets are something like this, wherein one end is inserted through the holes in the two sheets. They are aligned, and the rivet is inserted, and the other end of the rivet is made hot to the melting point almost, and then hammered with the help of hydraulic hammers. So it becomes rounded, and then it seals. If you see any of the old time, equipment, you will find, or even in the pictures, that rivets like these were very common, be it uh, storage tank, or be it ships, or be it even railway bogies. This is how the steel plates were joined before welding era. Titanic used something like 3 million rivets because it was made of steel. That time steel was a little different quality, but still it was steel. 3 million rivets were used. But unfortunately, to lower the cost, because there were 3 million of them, there was no quality control. It was an outsourced activity. It was not done in the shipyard. By the shipbuilder themselves. They had outsourced it without much quality control. And that led to this serious accident. If you have to pinpoint one point, this was the one point. Because of the poor quality control, there was excessive slag. Slag means there was excessive iron ore, which made it brittle, especially in cold, icy temperature of the Atlantic. And because of that, no sooner it hit an iceberg, the Titanic collision with iceberg caused the rivets heads to break off, popped the fasteners from their holes, and allowed water to rush in between the separated hull plates. This is something that has come to light only in last 30 years in this great detail. Like, say, for example, this is a metallurgical picture of one of the rivets that is found from the bottom of the ocean. And all the red spots that you see, they are slags or more, mm, brittle part of the. And you can see that so much of brittleness was there in the rivets. This is how the picture shows that when the rivets they were hit by the iceberg, they popped open and water gushed in. So after that, a lot of things have happened. Like, say, many of you are aware of SOLAS, Convention of Safety of Life at Sea. Many of you are using, and then North Atlantic, agency to look for icebergs, etc., etc. That is not the focus of I just want to bring attention that there is a PSM, asset integrity or mechanical integrity issue to this. Let's go to another incident, and this is about, as I told, Deepwater Horizon. Process safety management deficiencies. Again, I'll be quick because the time is running out for our meeting. This happened on April 20th, not very long back. Many of you are very much, you remember, because it was day in, day out on international TV, how the oil is bubbling from the, seeping, leaking oil rig at the bottom of the floor. Not oil rig, but the whatever was left from the oil rig at the bottom of the oil well, from the bottom of the floor, ocean floor. On April 20th, 2010, a multiple fatality incident happened 50 miles off coast of Louisiana. Control of the well was lost. That resulted in kick, and hydrocarbon came on the rig and then found ignition. 11 individuals were dead. 17 others were very severely injured. And of course, all rest of them had to be evacuated. Some of them, of course, jumped into the sea and they were taken, fished out of the water. Apart from that, there was a huge marine pollution backlash. In fact, this incident would be known for this uh, oil pollution. At least until now, this has been the largest pollution that we have known in our, oil and gas history. This is what we have been seeing day in, day out on the TVs all across the world. And this has been the unfortunate, picture of disaster. This is how the disaster unfolded on the southern coast of USA. BP was the main operator. However, it was the boat itself was operated. I mean, I won't say boat. The contractor, the drilling contractor, was Transocean. The name of the rig was Deepwater Horizon in the Gulf of Mexico, and at a place or at the location called Macondo. And this is illuminated. Rather, let me read this. The Macondo blowout has illuminated the potential severity of consequences from a single offshore incident and has served as a catalyst for examining major accident risk management in the offshore drilling industry and even on onshore drilling industry. A US judge ruled the BP repeatedly cut corners to boost profits. He described BP's action as reckless, gross negligence, and willful misconduct. But even others like Transocean and Halliburton, they were also negligent. And therefore, he apportioned 67% blame to BP, 30% to Transocean, and 3% to Halliburton. In its altogether, 184 million gallons were spilled out. And at the end, it has costed BP something like $65 billion. And even other companies suffered. Key investigation. Chemical Safety Hazard Investigation Board was assigned investigation in July, not in April. Normally, they are brought in for investigation right away, but in this case, only later it was recognized as an incident worthy of CSB investigation. The safety critical system, so they found some technical factors, safety critical systems responsible for shearing drill pipe in emergency. They found that this was one of the technical factors. Another very important technical factor was temporary abandonment plan, which is normally done for any of oil rigs. TA, with that it happened without a formal process. Nowadays, many of you who are in upstream would be wondering how this happened, especially with a company like BP. They lacked assessment decisions, including review of internal policies and standards to provide quality control. So these were the technical factors. There were human factors, lack of incorporation of human factors consideration into planning and execution. Another thing, here in human factors, I would like to that there were two devices. I won't get into the details. There is very good video available on CSB website. These two devices were miswired. It is, that is how human factors, human fault or maintenance in human factors in maintenance come into play. How small things, in the last incident we saw a small thing like rivet, here a small thing like solenoid being miswired, that played such a vital role in this incident. There have been several organizational factors with BP, with Transocean, even with Halliburton. All these details are given here. Risk assessment. The interesting part is that both BP and Transocean, the contractor, they had corporate policies on risk management, very structured process for risk management. However, when it came to working together, they did not practice their own policies, their own procedures on risk management in this case, which is surprising, but at the same time, that resulted in this unfortunate incident. Safety culture, out and out safety culture issue. And we will talk about safety culture when we are talking about Chernobyl incident. In fact, safety culture itself, the term safety culture was coined when they have been investigating Chernobyl incident. And lack of safety culture. In Ram Kumar presentation, he talked about safety culture, various stages of 5 stages of safety culture. In fact, CCPS, in their risk-based process safety management, they talk about a whole section about safety culture, maintenance of safety culture. This was the case even in this 2010 incident. Regulatory factors, lacks regulatory factors or absence of regulatory factors. In all the 3 incidents we will see, in Titanic, in Deepwater Horizon, as well as in case of Chernobyl, lack of enough regulations. Many people, they shout, especially in the free economies, in the free world, they talk about that there are not enough, there are too much of regulation. This permit, that procedure, this form, this policy, but sometimes they are required. In a society to have incident-free society, we may require right regulations, a balance of regulations. There was not enough regulation in the offshore in the Gulf of Mexico. So let's get into the recommendation, and you will find immediate connection to the process safety. One recommendation, or one of the recommendations, is about requirement for managing safety critical elements and developing guidance. This was required by, this was the recommendation directed to Bureau of Safety and Environmental Enforcement in Department of Interior of USA, that they should be doing this. Again, let me tell you that CSB recommendations are not binding. They are recommendations, and they can be challenged. They can be, sometimes they are very much at recommendations, and agencies or parties involved, they can say that no, we cannot implement this because such and such reasons. So another recommendation is to API, American Petroleum Institute, which is again a trade association, not a safety association. This is a trade association, API, but they were advised by CSB to have an offshore standard for effective management of technical, operational, and organizational safety critical elements. SCEs. Some of you who know what is this, uh, since last 10 years, people are talking about it very intensely. And if you are a PSM student, you should be knowing in more detail about this, or you should read about this, you should talk about this in more detail about SCEs. Uh, then they talked about so many other things, especially principle of risk reduction to ALARP level, hierarchy of controls. These are some of the things that were advised to have in their standards. They are writing a lot of RPs, recommended practices from API. So CSB advised them. Same way US Department of Interior, they were advised to have guidance on human factors and corporate governance, process safety, culture improvement. Another one was to Accounting Standards Board, Sustainability Accounting Standards Board, to have specific guidance and leading and lagging indicators for sustainability accounting. So these were some of the recommendations to them. Again, further recommendations regarding unloading of riser gas scenarios, robust risk management regulatory framework. This is still not there because this recommendation has not been implemented yet. And we now talk about safety management systems. So there were altogether about 50 plus recommendations, all indicating to process safety, alluding to process safety. Now let's talk about specific issues raised. Multiple safety management system deficiencies were there in both PP and Transocean as they implemented on Deepwater Horizon. And these deficiencies were highlighted, for example, safety metrics. In fact, like in BP Texas City refinery explosion case, here also the investigation found that between BP and Transocean, they had they won several safety awards before this incident. How come? Because all these awards were based on lagging indicators of not process safety, but on personal safety. That is, million man hours frequency rate, etc. So again, they failed to measure the right things. They were measuring something else while award was being given for safety. Hazard assessment. This is a major lesson from that they did not do proper PHAs, proper hazard identification and assessment. And because of that, major hazard, they were overlooked. And they focused on personal safety hazards. For example, fall from height. Yes, it is important, very important. But major hazards like blowout was completely disregarded. The control measures were mostly manual interventions. So if you have hierarchy of controls, if you go back the pyramid hierarchy of controls, you will find that manual interventions are one of the very less effective control process. We need to go for higher or more robust control, like, say, for example, inherently safer layers or maybe engineering control, etc. Operating procedure. No operating procedure for how to conduct negative pressure test, which was being done at that time. Can you imagine that such a crucial piece of process going without a written procedure? Again, it is out and out, like say even in OSHA, PSM standard, having procedures, written procedures, is a requirement. But here it was not done. Management of change. They kept changing during the week. So many times they kept changing the procedure. That means at the spur of the moment, as it came to their mind, like when they dreamt like this, they changed the procedure. So this is how, without a formal hazard assessment, changes were done. MOC was not followed. Again, OSHA 1910 PSM standard. Systems for investigating safety incidents were inadequate. They had some previous incidents with a similar incident like Mukando, but they were not communicated. The incident was investigated by Transocean, but they did not communicate. If you remember, Texas City refinery incident, similar thing was there. They were happening, there were 3-4 similar incidents happening around BP facilities, but the reports, the results were not communicated to BP Texas City. On Deepwater Horizon, BP investigated the incident, similar incident on the well itself, the very well, but Transocean did not implement the investigation findings. So these are some of the learning from past incidents, and learning were not implemented. Then why did they investigate? So I would very much take you to my reference, a very well investigated, well documented, and well presented, lots of pictures, explanatory notes, video clips are there. And I would like you to go back if you have not already done so, if you are a PSM practitioner. And lastly, I will talk about this very, very unfortunate incident, which people, they say that it may take 20,000 years, more than 20,000 people are killed by date. All these are models, and nothing could be told in very with any definitive way, but it was something that we must learn as a PSM practitioner. We need to learn. It should be part of your curriculum, part of your agenda, if you have not already done so. This happened on April 26, 1986. Chernobyl on April 26 at 1 a.m. Again, mind it, night shift. That should raise your, antennas. Night shift, when it is away from the limelight, when people are operating away from limelight. On April 26, the number 4 nuclear reactor at Chernobyl nuclear power plant exploded. The resulting fire spurred a crisis for the people of nearby city called Pripyat, north of Ukraine. That time it was part of USSR, and it affected not only in people in USSR, Belarus, Ukraine, etc., but even as far as Sweden, Norway, Germany in Western Europe. It is considered the worst nuclear disaster in history. I'm talking of when, talking of power plants, not of atom bombs. In fact, it is worse than even Fukushima in many ways. that happened in 2011 earthquake of Fukushima. The initial emergency response and later decontamination of the environment ultimately involved more than 500,000 personnel. They were involved in decontamination and costed almost 18 billion Soviet rubles, which is currently about 68 million US dollars. Very expensive. But more important than that is the human life lost and the eternity we are talking of next so many years. So this is what we call Chernobyl in the north of Ukraine. And this is Belarus, Lithuania, etc. They were that time part of Union of Soviet Socialist Republic. And then Poland. And here is Iceland, Denmark, Germany. So here you see Norway, Sweden, all these areas were affected to a greater or smaller extent. This is unit number 4. There were 4 units, 4 plants within the facility. And this is how the nuclear power plant, that particular type of nuclear power plant operates. I don't want to get into the details. The only thing I want to, of significance that I want to tell you about is that the power plant, the nuclear reactor is controlled by, among so many things, putting control rods inside. So the number two are the control rods. These black things you see, they are control rods that go down when we need to control the reactivity in the reactor. Means the more they are inside, the less will be the reactivity. However, there was a catch, and we will talk about this, that special design feature. This is what it looks like just before the incident. A normal control room in 1986, control room used to look like this, modern. It had its own computer, process control computer, devices, instrumentation, etc., etc. Trained people, well-trained people. And this is how it looks like after the incident. The whole thing was, there was an explosion, a major explosion, and the facility kept burning for almost 10 days. People, firefighters, they have been fighting fire. Initially, they have been, in fact, initial firefighters, many of them, they were unaware of the radiations. And that is why they had to lose their lives, because of the radiation effect. In fact, initial Western media, they reported that something like 2,000 people were dead. However, that was not correct. It was more Western media propaganda against their adversary, which was USSR. It was kind of height of Cold War going on that time. So this was how the British, newspapers reported. Obviously, it was not correct at that time. Although 20,000 people are considered to be dead by this time, however, these are chronic effect of radiation, not immediate effect. People, they were called liquidators. Liquidators were more like human robots. They have been brought from the army or reservists to remove the fragments of exploded reactor graphite, and they could remain only for some time, only 40 seconds, 45 seconds. If some of you have seen a movie from HBO or Skynet, they have made a wonderful movie out of this, based on this incident, and they were very ill prepared, very ill. Their PPs were very primitive, and they went there to remove the debris, the radioactive debris from the to make the whole thing less hazardous. This is how the Soviet television showed, and they said that no destruction or no gigantic fire, which was again not correct. It was more a mispropaganda. But one thing was very important that we need to emulate. You need to see that movie or you need to read the literature. The evacuation was decided much later. It was not immediately decided because the authorities, they didn't want to accept, as it is said, until Sweden, as far as Sweden, they reported increase in radioactivity, atmospheric radioactivity. Then only Soviet government, they acknowledged. But at that point, even though it was delayed, the decision to evacuate, a huge evacuation and very methodical, very systematic exercise was done. And this is a learning exercise by itself. Okay, it was delayed, it was much delayed, but we need to learn how a good evacuation could be done. And that is where people, those of you who are more into evacuation and emergency response, I would take you there, read about it, you know, do this, go this discovery route. Now, after so many years, sarcophagus, what they call a complete housing, the whole reactor has been put under a complete housing, and the whole area has become, not inside, but outside this. The whole Chernobyl area has become a kind of visitor's place. If you pay like a you are visiting a museum or you are visiting some novel place, it has become like that. You have to buy ticket, buy a tour, and you can be taken around, but not inside this, because radioactivity is so high that no one is permitted unless otherwise you are a research person. Let's get into very quickly events leading to reactor getting out of control. The accidents started during safety test. Mind it, safety test. It was a safety test on this particular type of nuclear reactor, RBMK. This kind of test was conducted earlier also 3 times, but they failed. This time, the fourth attempt, they have been doing, but there was a delay, 10 hours delay. So they scheduled it in the night shift when the operating shift was not very much prepared. They were not informed appropriately. And this risk was not made evident in the operating instructions. They were the operating instructions, in fact, either it was not there altogether, part of it, and parts were not correct also. At the end, the operators, when the test was concluded, or rather when the test was being done, the reactor became very unstable, which is not a likely condition that should be there in a nuclear power reactor. But when the test was completed, the operators triggered a complete shutdown of the reactor, as they know as a scram button. Many plants, they have like this. Some people are given authority to have a complete shutdown of the facility by press of a button. There was a similar button here, and that button was pressed. And then those control rods went inside. If you remember, I showed you picture at the beginning. the control rods were inserted in the reactor, thinking that it will stop the reaction altogether. Let's see further. A large amount of energy was suddenly released, and two explosions ruptured the reactor core. An open air reactor core fire followed by 9 days of rains all over USSR and Western Europe, west of because of the wind direction. This is radioactive fallout, they call it, the rain containing radioactivity. Finally, the whole thing could be contained by 4th May 1986. A massive emergency operation to put out the fire and stabilize the core, stabilize the reactor, and cleanup began. The reactor explosion killed two of the reactor operating staff immediately. In fact, until nobody knows what happened to them. 134 station staff and firemen were hospitalized. Out of them, 28 died almost immediately, and further 14 followed. The total eventual number of exposure-related deaths is anyone's guess. A model goes as many as 20,000 or 16,000 fatalities across Europe. This is how now tourists walk around Chernobyl. 10 kilometers initially and then 30 kilometers afterwards, radius, evacuation and exclusion zone has been made. Even today, radiation levels are too high within that zone, even in surrounding areas. And nuclear cleanup is expected in this area by 2065. Just imagine, many of us won't survive. That is why radioactivity is so dangerous. We cannot see it, but it is around. Estimate for when the site would be considered habitable again is 20,000 years, or sometime even more. That means people may not return to those areas in 20,000 years. And this is the exclusion zones. And this is one of the effects, radiation effect of animals in that area. The new births, a newly, I don't know what animal it is, possibly a dog, a puppy. This is how they are affected, newborns. In Sweden, they were taking measures with this kind of suit and, to counter the radioactive cloud of Chernobyl. Environmental impact, water bodies, flora and fauna, human food chain, you name anything and everything, abortions, cancer, long-term radiation effect, socio-economic impact, waste management. What is the humongous waste management exercise that must have followed? So, lessons for process safety. This is my last part. Some of you who are getting impatient, have some patience, and we will conclude very soon. There are lessons that extend beyond nuclear industry and beyond Soviet Union. Lessons are directly applicable to today's international chemical industry, PSM. The main cause was the reactor design. Every time I have been talking to you, apart from reactor design, the reactor control design was very much faulty. What was that? When you put the reactor control rods inside, it should stop the reaction. However, the control rods had something in their tip, what called graphite tips. And actually graphite tips, the control rod itself is made of boron, which controls the nuclear reaction. Good. You introduce boron and reaction stops. However, the rod, at the tip of the rod, there was graphite for various design reasons. And one of the reasons is cost cutting. The cost cutting reason was that they put graphite at the tip of the control rod. And graphite actually increases the reaction. It increases nuclear reactor activity. And that is the reason the reaction, when the shutdown button was pressed, the control rods went inside and increased the reactivity instead of immediately shutting it down. And that caused a huge reaction and increase in pressure and explosion. Of course, there were other reasons also. I don't have time to explain you all that. Now, let's come to the point. Contributing factors. What is PSM connection? Standards. The plant was not designed to safety standards and they did not have enough safety features incorporated. And I am not telling this. This is being told by someone called, I'll give you, INSAG, International Nuclear Safety Advisory Group, INSAG. They investigated the incident. In fact, Soviet Union, that time USSR, they opened gates to this investigative agency, neutral investigative agency, and they came out with this, that standards were not good enough. Now compare with your PSM, your plant standards, your mechanical integrity standards, your asset integrity standard. PHA, inadequate safety analysis was performed. There was not enough hazard analysis. There was not enough process hazard analysis. In fact, there was hardly any documentation on that. Safety reviews. There was insufficient attention to independent safety review. There was not enough independent regulatory body to monitor or review the safety features or safety plant design, etc. Operating procedure, as we have already seen, there was not much written procedure. Process safety information not adequately and effectively communicated between operators and between designers and operators. Designers did not communicate to operators. That means that the design manual, the design basis, the design features, the actual operating staff, they were not informed of, or possibly they were not trained on. Management of change, as we have seen, many of the decisions were taken during that night shift or immediately prior to that night shift, because they were running late. They were behind schedule. Training. The operators did not adequately understand safety aspects, especially the control aspect I talked about in detail. Operational discipline was not enough. Regulatory regime was insufficient, even though it was a communist country, communist bloc, where regulatory regime was normally considered to be very strict. Still, the regulatory regime was not good enough. And finally, coming to safety culture, let's look into more about safety culture. In fact, it was this INSAG group, that international group, that first coined the term safety culture, which gradually came into process safety also. And that is how CCPS in 2007, risk-based process safety management, they have given a whole lot of detail on, how to, what is safety culture, process safety culture, and how to improve it, how to implement the program, etc. Poor quality of operating procedure, accident can be have, flowed from deficient safety culture. And it was not restricted only to operating culture, but even during design, engineering, construction, manufacturing, every layer, the investigation found that the culture was missing. The safety culture was lacking in one way or other. And this has been reconfirmed by none other than, I would like you to see the person who wrote this. His name is Mikhail Gorbachev, Nobel laureate. He was the president of USSR when this incident happened. And 25 years later, he himself wrote this article. It is an interesting article, and all of you can gain from this. Now I will end with these two slides. I know I have taken a lot of time, but I thought that it will be some of you who are deeply, keenly interested will definitely like it, especially those who are in time zone that suits them. Common lessons from the 3 April incidents. I have tried to gather what was common in Titanic, in Deepwater Horizon, and this nuclear power plant disaster. All three in 3 different industry, not chemical or petrochemical industry by itself, but they had something for us as PSM practitioner. Common themes, artificially imposed deadlines. Titanic was running too fast. Deepwater Horizon, they were behind schedule. And Chernobyl, they were behind schedule. They wanted to catch up. Simplified targets in complex environments will lead to perverse incentives and unintended consequences. In all the 3, the crew, the shipping company, the, 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 the company BP, Transocean, even Halliburton, in Chernobyl, the people who were operating, the people who were managing, they wanted to get promotion. They wanted to get credit out of it. So their incentives were counterproductive to to safety, the very safety or safe operation of the business. Let me jump to good leaders listen. And all the 3 cases we have that there were leaders who did not listen. And again, it is not my invention. Get into the literature and you will find, get into the investigation report, how leaders, they stopped listening. And some of you who are leaders or who would become leaders in future, in fact, all of you are leaders in your own way. Be mindful that you have to have very large ears to listen. You don't get safety by rules and regulation. It starts with design and evolves with experience. Learn from this. Good design is iterative. It takes time, expertise, and feedback. It is very difficult, and that is where you have to respect experience. That is where, when you say that, okay, my operators have 30 years of experience, and therefore I can rely on them. Things happen differently in night shift. It is very interesting. In most of these incidents, people, like in Titanic case, most of the people were sleeping, not only on Titanic, but even those like in other ship, Californian, who could have saved 700 people, they disregarded because they wanted to sleep, in very blunt, if we put it very bluntly. Whatever the designer intended, sooner or later, the operator will do something different. This is a kind of Murphy's Law Ram Kumar has been talking about, especially in the night shift. Because when we operate, we don't think from designer's point of view. We think from operator's point of view, and our logic is different. I have been an operational person many years of my life, and I know in night shift how I think, how we think. When I am driving the car, I am not thinking the way the car designer or manufacturer has thought. My thought would be a driver's psychology, a driver's logic, which could be many times, much different. Sharing process safety information means sharing what went right, but more importantly, what went wrong. And that is the reason I keep requesting all of you come forward and talk about your failures. Don't be hesitant. Don't don't be ashamed. Don't be ashamed that I failed. I failed and therefore I learned. I failed to press the brake in right time and therefore I met an accident. This is what I have learned. Come forward, share that lesson. Don't be ashamed of that so that you can train me, you can teach me. And finally, management of change and a sense of chronic unease stops only when the field is green again. What is the meaning? Meaning is that when everything is good, looking good, that time also and that time only you learn, not only when things are in emergency. And this is something I would say a very important lesson for all of you, for all of us, for all PSM practitioners. Learn when everything is looking good, because that is when you can learn. Many times this question has come, oh, pandemic is going, what we can do? We have lost our job, or job load has come down. Well, this is a very good time to learn, to sharpen the saw, to sharpen your skills. So with this, I have come to an end, and I would get back to Ramana. Can you please take over if you are still awake?
Yes, sir. Thank you very much.
I would take only 3 questions on this. If some of you are still interested, please go ahead and and introduce yourself. I would like to get into 3 questions. There are still 62 people. I would encourage those who have not, asked any questions so far, or those who have not introduced themselves. It is a golden opportunity for, 2 birds with one arrow. You introduce yourself and shoot your question.
DTM Ram Kumar wants to ask a question.
Yeah, sure. Go ahead.
Ujjwal, Ritik sir, I thoroughly enjoyed. Actually, you made my day because.
Thank you, Ram Kumar. Let's listen from this gentleman.
Okay.
Go ahead, Ramanna.
I
Yes, sir.
I have a. Who is that? Can I ask?
No.
Someone who has not asked a question so far, please come forward.
Okay.
Yeah, go ahead.
Sir, actually, it's Mr. DTM Ram Kumar would like to ask a question for you.
No, I will answer Ram Kumar separately. Not to worry.
Okay.
I'm in live touch with him most of the time. Love you, Ram Kumar. Okay, someone who has not asked a question yet. Who is this Mr. Jason Logan? Are you still around?
Just a minute, sir. Let me unmute. Yeah. So Jason, you can unmute yourself now.
Mr. Jason? Hello? Are you still awake? You are still around? Let's move to another person called Lumity Trotsky. Lumity Trotsky. Are you there? Lumity Trotsky. You can unmute yourself, and if you have anything, any question. Another lady, possibly Mary Mutati. Yes, you have any question? Okay, it looks like that many of them have switched on and they want to take it easy. So let me open it again.
Yeah, let me open the chat. This one, unmute.
Yeah, unmute the chat box.
Yes, yes, yes. Yeah. Yeah, now everyone can unmute themselves. Whoever would like to talk, we can talk freely.
Hello. Yes, sir. Myself, Sampath sir from India.
Yes, Mr. Sampath. Go ahead. You have any question on any of the three incidents?
Sir, in that I have seen that, sir, what are the motivation you have given? It's 100% correct, because we learn from the failures. That one thing. Even there was some scenario, it was mentioned that the operator also has done some wrong thing. But anyway, the failure is failure. We cannot able to correct the failure. But we can able to go ahead with the success factor of the failure, like instant learning, or we have many other reasons. But all these things can help us as a HS statistics for us, so that we can able to go or make the safety culture in a well planned manner, so that
correct. But yes, Sampath, do you have any question that I can quickly answer, or maybe?
Sir, I had a small question, sir.
Yeah,
it's
sure.
not with the safety audit assessment. In that part, I had one doubt at that time. I want to ask, but anyway, after seeing your conversation, I just want to ask this one instead of Ram Kumar sir, because your experience can able to teach many other people, so in a positive way. So I just want to ask now in this situation. The thing is, right, sir, in planned maintenance, generally I'm saying, sir, anyway, the checklist is also we consider as a planned maintenance. In that, it was mentioned that maintenance backlogs are common. Okay, sir. There was some case there, okay, where it says that there is a regular scheduled maintenance checks, but maintenance backlogs are common. Definitely, because if any equipment is there, definitely there is chance for breakdown and everything will happen occasionally or periodically if any failure from maintenance or anything. So in this case, so the best we can able to assure that doing preventive maintenance not only develop that equipment fitness, but in this case, why can't we go for the competency of operator after getting some level of experience? Because generally, what are the operator we are going to engage, he is already having a competency. So how we can able
yes,
to improve
Sampath, I very much agree with you. Absolutely, there is no doubt about it. Let me give you a very common and simple example. If you are driving a car, any car, the driver has to be trained as much as the one who has manufactured it, the technician, as well as the person who has been maintaining it. You cannot take your car, let's say, an expensive car or even inexpensive car, you cannot take it to a mechanic whom you do not rely, who is not trained. So all aspects are design, maintenance, operation, all three are important. And that is how asset integrity has come. In fact, it is a parallel practice which is sharing a lot of space with process safety management, and we need to be very, very mindful of. Thank you for highlighting that. Let me go to, I think Mary was there. Mary, can you come back again?
Sir, 1 minute. Sir, 1 minute, sir. If you give a couple of minutes, I want to talk about you, sir.
I'll come back to you, Sampath Kumar.
Okay,
I'll
sir.
come back to you. Problem
Sure,
is
sir.
that we are running, we have run
Yeah, okay, sir.
awfully
Short of
out
time.
of time. So we
Okay,
need
sir.
to be, responsive to all. Let's talk about, Mary, you were there.
Yes.
Go ahead.
Yeah.
Can you introduce, and if you have any question, shoot
my
it.
My name is Mary Muteti from Kenya, Nairobi.
Welcome.
I'm very grateful for the insights. I've gotten a lot of information and I'm just here to learn more about process safety. I do not have a question right now, but I'm very grateful.
Feel free anytime. You can shoot a question, a suggestion, anything you think about. You just don't feel hesitant. And let us take one more last question. Anyone? Again, those who have not asked questions so far, I encourage them to come forward.
CPV and Paula is there.
Okay, go ahead.
Okay, thank you so much for the opportunity. Yes, I've heard that we have, it's pure from Zimbabwe, Harare.
Yeah.
Yeah. I've heard that we have talked about process safety. The definition has been well explained. We also talked about the key elements, which includes operational discipline, which also includes operating standards and regulations. Now my question is, how best can we implement the process safety? Like for instance, on a biodiesel production plant. That's my question.
Ram Kumar, you want to answer or shall I go ahead? Ram Kumar, you are mute. Okay, let me, for the sake of time, let me, CPV, see, you have asked a very big question. And if we try to answer you in 1 or 2 sentences, or even in 1 or 2 paragraphs, you will get misguided. And that is something I don't want to do. You are a student, you are still a student. I can give you some jargon and get away with it that, okay, this is the way you should implement it. But it is not that easy. Safety, process safety is let me say, safety itself is part of operations, part of running a business.
Okay.
You cannot say that safety is separate than driving. You cannot have a separate safety officer sitting at the back of your car who you say that I have nothing to do with safety. My job is only driving, and he is the guy who is taking care of safety. No, there is nothing like that. If you are the driver, you have to take care of operational safety, right? If you are the maintenance mechanic, you have to take care of maintenance safety. Now, coming to process safety, it is a branch. It is a branch of safety wherein we talk about major hazard control. Major hazard due to any facility, normally due to chemical facilities. Although it can be extended to nuclear facility, even to the, to dams, to utilities, to other plants and all that. So since you are a student, and if you are interested further in process safety, you can start with something very simple. And I would give you a very quick, introduction, that you look into process safety Wikipedia. Okay, you will get something like in half an hour to 1 hour time frame, you will come to know essentials of process safety management, process safety business. And then that will take you to tons and tons of literature, free literature on process safety. And beyond that, we are, you can always shoot a mail to us, and it will be our privilege to, help you, assist you anyway. Thank you for joining. And it's now time for Ramana to run the quiz. Ramana, yes?
Yes, thank you very much, sir. Now I'm going to pose the quiz. Please just give a few seconds. Okay. I have posted the quiz. Now there is a link. Please go through it and you can participate and get the certificate of participation immediately. Not immediately. We stopped that one. Earlier it was sending immediately, but we
So
stopped.
by tomorrow or day after, you can send them the
Yes,
certificate.
yes. Yeah, within a day.
You will get a certificate of participation that you can use as a, if you are having some credential maintenance program, then you can use these. So go ahead and participate in this quiz. We give a few minutes. In the meantime, I would like anyone to come forward and introduce if he or she has not been able to do so far. Yes? I see a lot of people. I don't know, my good old friend, first time I'm seeing him joining from UK, or he has left. Okay. He was there until recently, so since he has left, I won't call his name. And we have Abul Wafa Firdausi. I did not see this name before. Can you unmute yourself and introduce Abul Wafa Firdausi?
He's our new member, so recently joined.
Oh, okay. I never seen him before. There is another lady called Funda Efsen.
Yeah.
Funda Efsen. Never seen this before. So please unmute yourself and introduce you. We would like to have to listen from you. Welcome to the forum, Funda. Another one is Gladys Niaga. I think a couple of meetings back, we had heard from this person, Gladys Niaga. Are you still around? Gladys Niaga? Ibtisam Saeed, are you there still?
Hi, yes.
Yes, Ibtisam, welcome. Welcome to this forum.
Yes, thank you. I'm from Kenya.
Uh-huh.
Yes, I work with an LPG terminal here in Mombasa.
Mm-hmm. Wow, wow.
Yeah, I'm a safety practitioner and I got interested in PSM since last year. So I've been reading about, especially when I interact with now the pressure relief valves, all instrumentation. And basically PSM is a new concept. In our country, we still don't have any legislations, any regulations with regard to it. When we interact with our colleagues, mostly those who work with international companies, like I can say Total, those are the people who have implemented PSM within their facilities. But within the country, we are yet to have legislations. Yes, yes.
Wonderful to have you and to listen from you. Please keep joining our forum, and we will learn from you as much as you will learn from rest of us. So
yeah,
thanks
thank
again.
you for the opportunity.
Yeah. There is Irene Mueni. Irene Mueni. Or if I have mispronounced, I'm sorry. Is it Irene Mueni? Also, I am seeing almost for the first time Jasar Rumani. Is he a member, Ramana? Jasar Rumani, sorry.
Hello, sir.
Yeah. Welcome.
Yes, sir.
Welcome, Jasar. Please
Thank you,
introduce
sir.
yourself.
Myself, sir, Jasaru Mane, working
Mhm.
as a HSC supervisor in Gas Trench Fire Project in Mina Al Ahmadi, Kuwait.
Welcome. And is this your first time on this forum?
No, actually, I have attended this 5, 6. I think this is 5th one section, man.
Wow. Oh, and we did not notice you. Then you should start asking questions. Man,
Sure.
you raise your hand, make some noise.
Sure, sir.
Do you find, I can say that since this is your 5th one, I think you are finding it of some value.
Yes, sir.
Wonderful. Keep joining and, spread the word around. Let others also be benefited. Because
Sure.
what Ramana says that unlimited number of people can join this meeting.
Right,
That's the
sir.
advantage of online meetings.
Right, sir.
Wonderful. Ramana, can we close the
Yes, sir.
quiz now?
Yes, sir. We can close. Okay.
Sir,
I'm going
sir,
to.
Sampath here, sir. I want to talk a couple of minutes about you, sir. I'm just waiting because also I just missed many of the opportunities to attend the session, sir. But I was knowing you, sir, because my previous colleagues and seniors, they're also in contact with you. So I'm just eager to listen your sessions, and everywhere I was just waiting for you. Even you can see I am from India, sir, and I don't have any relation with PSW also, process safety also, because I'm in construction field purely.
I can understand.
But still, I was eager to work in construction to PSW in future also, or else even right, I have taken one inspiration from you to start CRSP. I think you remember or not, I don't know, you have many degrees. In that, your Canadian certified professional safety is one of the thing which I took motivations like many things. Next, my target was that, but my base agenda or base motivation part is you behind me. So I have tried many ways to attend your session, sir.
I'm honored to know. Thank you very much. And please keep joining these sessions. And if you want to know further about process safety management, you can just shoot a mail to the chapter and you will come to know. Just now I was talking in general to everyone. Start your journey with Wikipedia. It will help you a lot. Now, let's go to our president, Mr. Jahid Thakur. If he is here, he can, give us a few words of encouragement.
Thank you very much, sir. Yes, sir, I am here, sir. You can hear me, right?
Yeah, very much.
Yes.
I am sitting in Arlington, Virginia, USA, and I can hear you from here also.
Yes, sir. Thank you. This is the beauty of the technology. And once again, really from bottom of my heart, very, very thank you to all today's participants. I can see it starts sharp on 8:30 here in Kuwait time. And now almost 11:15. So 2.5 hour journey, we did not feel any single second or minute that, okay, we are where, because we did not take any calls and the other things like in the month of fasting. Still, after finishing the pray, I joined a little late, 5-10 minutes. But the single minute, I did not want to lose the knowledge sharing by guru of PSM and our today's speaker, this Ram Kumar. Really, sir. And I salute you, sir, and Ashok sir also. I can see each and every session, our advisory committee members, they are the backbone of ASSP Kuwait chapter.
He is
and
the
we
boss.
feel really proud.
Thank you, Jahid. Now, Ramana, you want to go further and invite our vice president for closing remarks?
Okay, sir. Thank you very much.
Before we close, from my side, from moderator our coordinator side, let me thank first of all Mr. Ramkumar. An excellent presentation. I know him, so if I talk more about him, it will be biased. But thank you, Ramkumar. And
Thank you, sir.
something I want to talk about Ramkumar, it will be incomplete because of his, the honor he got from Toastmaster International. Now he is the boss of Bahrain and Kuwait, 2 countries. So we are honored to be in his company. Thank you, Ramkumar, for that as well.
I'm honored,
and,
sir. Thank you.
Thank you, all of you who joined. Thank you, all of those who posed their questions. And I will not be satisfied with this. I want all of you to, by rotation, or compete among yourself to present or not to present, to talk on this forum. This is your forum. Utilize it. You see the kind of spread it has got right from Australia to Argentina. All time zones we are covering. So please go ahead, and thank you, all of you, very much. Over to you, Ramana, and then to the Vice President, to give the closing remark.
Thank you, sir. Thank you very much. Now, on behalf of our Vice President, our President itself, President himself, Mr. Jahid, is going to give the closing remark. Mr. Jahid, please.
Thank you, Ramana. But before going to vote of thanks, I would like to call our advisory committee member and the backbone of Kuwait chapter, Ashok sir, for a few briefings about today's session. Ashok sir, please.
Thank you, Jahid. Thank you for inviting me. I was listening to Mr. Ramkumar and Mr. Ritik sir for almost 2.5 hours plus, and from all the voices from Australia to Argentina, it's glad to know that actually it's the first time we have got such a global participation. I think we need to change our PSM seminar to the global PSM practice specialty. That looks good. Thank you. Thank you. We are utilizing this Ramadan time to learn also, and looking forward to sessions. Thank you all for participating.
Thank you, sir. Thank you very much. Now, on behalf of ASSP Kuwait chapter core committee, I would like to thank our today's speaker, Mr. Ramkumar and Ujjwal Rutvik sir. Really very wonderful session, and almost 80 to 90 participants they had started, and till end of the session there were 75 to 78 people and attendees were there. And you had covered many things, especially Ramkumar and Rutvik sir. Most of the incidents related to process safety management, and you had thrown light on Titanic, Deepwater Horizon, Chernobyl incidents, and you had touched the importance of process safety management, especially operational excellence, importance of training, mock drills, safety device, safety critical equipment, and safety cultures. I would like to thank all participants who joined from other parts of the world like Australia, Argentina, Pakistan, Zimbabwe, Kenya, and many more. Please be connected. Mark your calendar. Each month, third Wednesday, we are organizing this process safety management technical meet, and we welcome all of you from all parts of the world. And on behalf of ASSP Kuwait chapter, I would like to thank our today's moderator, Ujjwal Rutvik sir, Ramanna, Riaz, and all participants. We pray Almighty God to bless all of us and end this pandemic very soon. Thank you very much. Good night. Over to you, Ramanna.
Thank you very much, Jayaji. Since it's time delayed, we are going to close the meeting now. Next time, in the next meeting, we'll be having short presentations and more network time will be there. So I request you to bear with this, and we are going to end the meeting now. Thank you very much for the opportunity.
Thank you,
Very
Raman.
much for the participation.
Ramana, there is no facilitation. Ramana,
Yeah, please.
there is no facilitation slide for the presenter.